So in this section we're going to be looking at WAN technologies. Dedicated lines like the T1 and the T3, the ISDN, which is a fraction of a T1, DSL, digital subscriber lines, frame relay X.25, SMDS, ATM, and then finally we'll finish up with voice over IP. With dedicated lines, we're talking about wires that are pulled from point A to point B. In other words, there is an unambiguous destination. There's only one place these wires are going to go. They call these point-to-point connections. These are typically like the T1 and the T3. This point-to-point connection is also used in satellite, but of course in the case of satellite we're using radio frequency transmissions over the airwaves. We're not using cabling. In this case we're talking about cabling due to the dedicated lines. So the T1 operates at 1.544 megabits per second and a T3 operates at approximately 45 megabits per second. ISDN, Integrated Services Digital Network, is a subset of a T1. This is a T1 to the connection office for the telco, and then they'd pull an ISDN pair of wires to your home, for example, or your office. This is referred to as the last mile. And this provides slightly higher data rates than a standard analog connection using the old screechy modems, but is relatively inexpensive. It uses circuit switching instead of packet switching. Circuit switching is where, when the connection is made, your connection path, the wires between you and the destination, are locked in and you own that connection. You own those wires for as long as your connection is made. Once your connection breaks, those wires are released back and are available for other connections to be made from other clients. But when you call back, you lock in your own connection path again and you don't share that connection path with anyone else. So that is circuit switched. We'll talk about packet switching later on. ISDN is an on-demand service for most users. In other words, we don't dial up and stay dialed up. We dial up only when we need to. This helps reduce the cost. Typically, the ISDN is a fraction or a small component of a T1 connection. It uses typically two B channels, two bearer channels, and a single D channel for the connection. The BRI, or basic rate ISDN, as I indicated, uses two B channels and one D channel to give you 144 kilobits per second. Now, this is two B channels out of the 23 B channels that make up a T1 connection. So the T1 gets broken up into many different ISDN channels, and that T1 can then be shared amongst many different subscribers in the ISDN connection. The next WAN technology we'll look at is called DSL, or digital subscriber lines. DSL is another one of these last mile technologies. DSL is an always-on technology. In other words, when you get connected with DSL, your connection through DSL stays connected 100% of the time. This is a good thing and this is a bad thing. The good news is you don't have the delay in making your connection to the internet to get your email or to get to your favorite website. The bad news is because you're on 24/7, bad guys have 24 hours a day, 7 days a week to break in and exploit your system. So this has led to a great deal of increase in the number of what we call zombies. A zombie is a compromised client computer that is available for the bad guy to perform whatever malicious attacks he cares to do. DSL operates at a high frequency. High frequencies attenuate over distance, and as a result there is a maximum distance that the subscriber can be away from the connection office, the CO, and still receive a worthy signal. The further away from that connection office, the lower the bandwidth for the DSL connection. This is why DSL doesn't necessarily guarantee a high rate of information flow or bandwidth. It is subject to the distance you are physically located away from the CO. There are two flavors of DSL. The first is called asymmetrical or asynchronous digital subscriber line. This is where the connection is optimized for download to the client. This is the way most users use the internet. They upload a few mouse clicks and the tiny couple of bytes for a URL, the web page that they're trying to get to. So very minimal amount of data uploaded, but a great deal of information downloaded. ADSL optimizes for that type of traffic. Lower bandwidth upload, greater bandwidth download. This is asynchronous or asymmetrical DSL. The other flavor is synchronous or symmetrical DSL, and this is where you have the same upload rate as you do download rate. Generally, the two rates will be lower than usual, but they are balanced at least. This means you can provide some services to the internet. In other words, a fair amount of upload as well as a fair amount of download.